All right, so we have the word problems. We have some step functions going on. So if we look at number 7, it says a stitch in time charges $40 per hour or any fraction thereof for labor. Draw a graph of the step function that represents this situation. So here's what they're basically saying. It's sort of like that greatest integer step function that we were looking at in class. What this basically means is they're going to round up to each additional hour, whether you've used them for the full hour or not. So basically, if you use this company and they work from 0 hours to 1 whole hour, they're going to charge you $40. So we can graph that right here. We can say from 0 to 1 is at the $40 mark. Then from 1 hour to 2 hours, they're going to charge you $80, but not exactly. Anything over 1 hour to 2, so we'll have a hole at the 1. And then same thing, when we're at 2 hours, we have a hole at 120, but anything above that from 2 to 3 is going to be $120. Sorry, it's a little sloppy there with my finger. There we go. From 3 to 4 hours, we move up to 160. From 4 to 5 hours, we go to 200, and so on and so forth. Okay? So that's what that one is. Notice the hole is in the different spot compared to the greatest integer, and that's because of the way this problem is worded. You know, when you go from 0, obviously if they work 0 hours, you're not going to pay them $40. But right after they start working, they're at the $40 mark until you get to 1 hour. Okay? And then it jumps up to $80 once you go over the 1 hour mark, and so on and so forth. Okay? A wholesaler charges a store $3 per pound for less than 20 pounds of candy, and $2.50 per pound for 20 or more pounds. This is a piecewise function, so this is basically saying your amount is 3x if x is less than 20, and 2.5x if x is greater than or equal to 20. Okay? And we're saying f of x, where f of x is the amount of the cost for the pounds. So if we go to 20, kind of like we've done with the piecewises, we can go from there and put our 2 points. So when x is 20 for the first function, I get $60. But remember, that's for strictly less than 20 pounds. So we're going to have a hole at 20, 60. And then at 2.5x, I've got 50. So that's going to be a solid dot there. I'm going to approximate it. Okay? So, I'm going to connect my dots for 3x. Notice how they arrange the values. If you go down 15 on the y coordinate from 60 to 45, and to the left 5, that would be the same thing as going down 3 and over 1, which is the slope of this first function. So that's why I'm able to use the corner points. They kind of helped me with that by the way they ticked off their 2 axes. Okay? Now, I'm at 50. I want to go up 25. So the second slope is 2.5 over 1. But that doesn't help me because I don't have 2.5s and 1s on here. But what I do have, if I move the decimal point one place over, I can go up 25 and go to the right 10. So if I go up from 50, 25 of that is 75. I have that on my y-axis. And then I go to the right 10. That's going to be 2 boxes. That gets me a second point. And once I have 2 points, I'm good to go with my graph. Okay? So these were just some other examples of how to use a step function in the real world for number 7 and a piecewise in the real world for number 8.